In this lesson, we're going to learn how to find the product of a monomial and a polynomial. We're going to use the distributive property, and we're going to multiply 6y times each term inside the parentheses. I don't normally write that line out, so I just wrote it out paused. So I have 6y times each term, and this is what I would normally do after I drew those lines. I like drawing the lines. So I'd have 6 times 4 is 24, y times y squared is y cubed. I have 3 factors of y now. Positive times a negative is a negative, so instead of going plus negative, I'm just going to write minus 54, y times y is y squared. And positive times negative is a negative again, 6 times 7 is 42. And there is no other y, so it's just going to stay y. We can also look at expressions that have more than one multiplication by a monomial in them. So the 3 is outside that polynomial, so I need to take 3 times all 3 terms. So that's going to give me 3 times 2 is 6, just going to say t squared minus 12t minus 45. And then the same thing, I'm going to take 6t times both of those terms. So it's going to be plus 30t squared plus 12t. And I want to rearrange and add my like terms. So I've got t squared, so let's just put those by each other. And then I have t's. Oh, those are actually additive inverses. Goodbye. And then we have the minus 45. So all I really have left to combine is the t squared, so I'm going to have 36t squared minus 45. It's what that whole mess simplifies down to. Not bad. Admission to the super fun amusement park is $10. Once in the park, super rides are an additional $3 each, and regular rides are an additional $2. Sarita goes to the park and rides 15 rides, S of which are super rides. Find the expression for how much money Sarita spent at the park. If we let S be super rides, and just for a second here, I'm going to let R be regular rides. And she rode a total of 15 rides. So then we'd have S plus R equals 15, but I really only want one variable. They said S are super rides, so I want to solve that for S. So R, my regular, is going to equal 15 minus S, if I just subtracted S from both sides there. Okay, so going back to our word problem, when she walks in the door, she has to pay $10 no matter what. Plus it says she pays an additional $3 for each super ride. So that's the variable we're keeping, so 3S. And regular rides are only $2 more, so 2 times, okay, so for regular we have 15 minus S. And I can distribute that. So I have 10 plus 3s plus 2 times 15 is 30. 2 times negative s is negative 2s. And we're going to combine our likes. I'm just going to set them next to each other for 1 second here to make it easier to see. You don't necessarily have to do that step, but if it helps, do. So 10 plus 30 is 40. And 3s minus 2s is 1s, and we don't normally write the s. So she spent $40 plus however many super rides she went on. So the easy part is to evaluate the expression to find the cost if she rode 9 super rides. So all we have to do is 40 plus 9 is $49. Hope she had a good time.